Everyone, the topic that we are going to discuss today is introductions to number systems. From the first chapter, number systems. Maths is all about numbers. Everything that you learn in mathematics is nothing but different forms of numbers, patterns, actually not just maths, but all the physical phenomena, natural phenomena. Everything can really be explained using numbers patterns. So these numbers patterns are the very core of all maths or all nature. Let's look at a very simple number pattern, a counting number. Let's say 1, 2, 3, 4, 5, and so on. What are these set of numbers called? This set of number is called natural number. It is normally represented by n. We can count everything, for example. Now there are 3 apples inside a basket, so the number of apples can be represented by a natural number. Now, if we remove all the apples from the basket, how will you represent the number of apples left in the basket now? You can't. We know bring in a 0. So if we include 0 to the set of natural number, we now get whole number. It is represented by W. Now what happens if we subtract 4 from 2, that is 2 minus 4 equal to minus 2. Now minus 2 is not a whole number. To be able to represent minus 2, we add another set of number to the left of 0. These are nothing but negative of natural numbers. This entire set of number is called integer. It is denoted by I. Do we now have all the numbers possible? Seems like a lot, but not really. Let's zoom into a section 0 to 1 of a number line to see. Between 0 and 1, we have 1 by 2, that is half. And between 0 and 1 by 2, we have 1 by 4, and so on. We will get infinite set of number. These are not integers. They are called rational numbers. Let us see from the definition of rational numbers now. The numbers which can express in the form of p by q, where p and q are co-prime integers and q not equal to 0. It is denoted by q. Example of rational numbers: 0, 1, minus 3, 1 by 4, minus 1 by 2, etc. All these numbers are in the form of p by q. For example, say 0. 0 is nothing but 0 by 1. 1 also is written as 1 by 1. Minus 3 can be also written as minus 3 by 1. They are in the form of p by q, where the denominator, that is q, not equal to 0. What is co-prime? Let us try to understand first. Two integers are said to be co-prime if the HCF is 1. Example 4 and 5, 6 and 7, etc. Here, the HCF of 4 and 5 is 1 because there is no common factor other than 1. So these two numbers are said to be co-prime integers. So, from the definition of rational numbers, 5 by 10 is not a rational number, but it is the equivalent of a rational number 1 by 2. Since there is a common factor 5 between 5 and 10. So we can write 5 by 10 equal to 1 by 2. So 1 by 2 is a rational number and 5 by 10 is the equivalent of 1 by 2. So we can say that all natural numbers are whole numbers, all whole numbers are integers, and all integers are rational numbers. However, the reverse is not true. Now let us see another set of numbers called irrational numbers. Until one of the Pythagoreans wondered, how do we represent square roots of 2? There is root 2. He was interested in root 2. He looked at his number line and realized that it cannot represent this because there are no two numbers p and q such that root 2 equal to p by q, where p and q are co-prime integers and q not equal to 0. The same was true for the constant pi, where pi is equal to circumference of a circle divided by the diameter of that circle. For calculation, we use the approximate value of pi as 22 by 7 or 3.14. This is for convenience. Actually, these are not the real values. The value of pi in decimal form is equal to 3.1459263 and so on. So it cannot be expressed in the form of p by q, where p and q are co-prime integers and q not equal to 0. So let us see the definition of irrational numbers now. This number which cannot be expressed or represented in the form of p by q, where p and q are co-prime integers and q not equal to 0, are called irrational numbers. Examples: root 2, root 3, root 5, root 6, and pi are some of the examples of irrational numbers. Let us see what is real numbers now. We should also remember that rational numbers and irrational numbers are two separate sets of numbers. The number which is rational number cannot be irrational numbers. The number which is irrational numbers cannot be a rational numbers. In a very simple way, we can say that irrational and rational numbers are two different sets of numbers. Now, if we combine the set of rational numbers and the set of irrational number, we have a real number. So, together form a set of numbers called real numbers. Now, let us try to solve some of the questions related to irrational numbers. So, let us take the first question. Prove that root 2 is an irrational number. In order to prove that root 2 is an irrational number, we are going to assume that root 2 is a rational number. So let us suppose that root 2 is a rational number. Since this root 2 is rational number we can express in the form of p by q. So root 2 equal to p by q, where p and q are co-prime integer and q not equal to 0. Implies that 2 equal to p square by q square, squaring both sides. We have now p square will be equal to twice of q square. Since p square is a multiples of 2, so p square is an even number. Since it is 2 times something, from this we know that p itself is also an even number. So we can express p equal to 2k, where k is some integers. If we substitute p equal to 2k into the original equation, that is 2 equal to p square by q square, we get 2 equal to twice k whole square divided by q square, which is also equal to 2 equal to 4k square by q square. On transformation, we have 2q square equal to 4k square, implies q square equal to twice of k square. This also shows that q square is an even number. Since q square is an even number, q is also an even number. That means there is a common factor of 2 between p and q. And that is contradicts, because we started that p and q are co-prime integers. Thus our original assumption that root 2 is a rational number is not correct. Therefore, root 2 cannot be a rational number. It is an irrational number. Let us take another question. Prove that 3 plus root 5 is an irrational number. Here is the same case. Let us suppose that 3 plus root 5 be any rational numbers. We have 3 plus root 5 will be equal to p by q, where p and q are co-prime integers and q not equal to 0. Implies that root 5 is equal to p by q minus 3. Implies root 5 will be equal to p minus thrice of q divided by q. Implies root 5 will be equal to m by q, where m equal to p minus 3q. P and q are integers, therefore m is also an integers. So m and q are co-prime integers and q not equal to 0. Here the left hand side is an irrational number, whereas the right hand side is a rational number. This is not possible since the number cannot be both rational and irrational numbers. And that is a contradicts to our assumption. Therefore, 3 plus root 5 is an irrational number. Operations on rational numbers and irrational numbers. When a rational number is added with irrational number, the result is always an irrational number. When a rational number is multiplied with an irrational number, the result is always an irrational number, except for rational number 0. When 0 is multiplied with any irrational number, the result is always 0. Third, when a rational number is divided by an irrational number, the result is always an irrational number, except for rational number 0. That is, when 0 is divided by any irrational number, the result is always 0. Next, let us see the sum, product and divisions of two irrational numbers. When you add two irrational numbers, the result may be a rational numbers or an irrational numbers. For example, when root 3 is added with root 2, you get root 3 plus root 2, which is an irrational numbers. Whereas when root 3 minus root 3, you get 0, where 0 is a rational numbers. Next, when an irrational number is multiplied with an irrational number, the result may be a rational number or an irrational number. For example, when root 3 is multiplied with root 2, you get root 6, which is an irrational number. Whereas, when root 3 is multiplied by root 3, you get 3, which is a rational number. Divisions. When an irrational number is divided by an irrational number, the result may be a rational number or an irrational number. For example, when root 3 is divided by root 2, the result is an irrational number. Whereas root 3 divided by root 3, you get 1, which is a rational number. For your homework, I'm giving you 3 questions. The first question is, prove that root 3 is an irrational number. Second question is, prove that root 5 is an irrational number. And the third question is, prove that 6 minus root 7 is an irrational number.